So if you come out here to the Annex Mine State Park on a fossil tour, you think you might not be able to find a fossil. It's just something you've never done before, but trust me, we can help you find a fossil. Almost everybody goes home with a fossil when you come out here on a tour. And just to prove it, my director is going to have me find some fossils for you. And usually when I find a fossil, I'll flag it so you can come over and use your own eyes, take a look and see where it is. That helps your brain form an image and helps you start finding fossils faster. So the challenge, I got 5 flags. We got less than 10 minutes. How long was it going to take me to find 5 fossils? This is how fast you can find a fossil here at Annex Mine. Just 4 little fossils right there, 3 partial snails, 1 tiny clam, and 1 mussel that I lost on the hill. These would be from the period of the dinosaurs, late Cretaceous, about 90 million years ago. These would have been snails that lived here on the shoreline or up the river or in the swamp. And you can see it's what we call a whorl, W-H-O-R-L. And just one part of the twist of a snail, how it goes up like a cone. They very, very often will fall apart as they start eroding out of the hill. And this one is just a very small little clam. Right along the backside right here, there would be a little seam, but it's covered with dirt right now. So, welcome. This is your presentation today on paleontology for the Iron Range Science and Engineering Festival. Today's agenda, we're going to talk a little bit about background. We're going to go over some terminology. We're going to talk about where Minnesota sits in the time period that I research. We're going to talk about some of the things that we find. And maybe at the end I will give you a link so that you can send me questions if you have anything following up after our talk. I'm John Westgaard. I'm the Annex Paleontology Project Director and one of its 2 co-founders. I have a degree in psychology with a biology minor, and I studied animal behavior, so I was a field scientist when I was younger, mostly chasing animals around the woods. In 2007, I started at the Science Museum of Minnesota, and in 2009, I became a volunteer there in the paleontology lab, and that's really where my curiosity and interest in fossils and paleontology got rekindled. My inspiration here is one of the, and why I do this research, is one of the things that I was told and when I was getting trained to work at the Science Museum is that we didn't have any dinosaurs here in Minnesota. There's no real evidence of any dinosaurs. We don't have Cretaceous soil. And it didn't take long, just a couple of months, and I started finding some evidence that was to the contrary. One of the museum's own publications, and there's a slide that you'll see here. There's a hadrosaur vertebrae. This is just a little bit smaller than a softball, and it was found in Crow Wing County. So right away, some of what I was told, I was taking into question, and science is so much about questions. I started looking a little deeper and found out that this one bone actually was found in the same county where I was born and could possibly have come from some old iron ore mining pits and dumps that I used to run around all the time when I was a kid. So it kind of prodded my curiosity. Had I actually, as a kid, walked across a dinosaur bone and never bothered to look down and find out. So that's part of what really inspires me to do this work. Time for some vocabulary. First of all, paleontology and what is it? Basically, paleontology is the study of past life, and this is usually preserved in some form of fossil. A lot of people make this synonymous with archaeology, and archaeology is its own science. It is also the study of past life, but it's all centered on human life. Fossil is simply the remains or impression of a prehistoric organism preserved in a petrified form as a mold or a cast in rock. And you can find all sorts of different examples of soft-bodied animals and shells and bones and teeth, leaves and wood. A few more weird words that I'm going to have to share with you today that will help you understand what we're talking about. Stratigraphy. Stratigraphy is the branch of geology concerned with the order and position of strata and their relationship to the geologic time scale. And strata is simply the layers of soil and how they lay on each other. Matrix, you can see behind me, a whole bunch of matrix. Matrix is just simply the rock or soil that the fossils are contained in. In situ means that we're finding the fossil exactly where it laid down and was preserved. This pile behind me is a spoil pile, so it came out of the iron mine pit. And all this material was dumped here. So these materials are no longer in situ, they're just collected together in one pile. And lastly is ichneofossil. Ichneofossil is merely the trace of life. So it can be a footprint, it can be a fossilized poop, it can be a scratch mark or a bite mark. Anything like that is considered an ichneofossil. You'll see a picture here of the mine pits, and you can see the layers on the side of the pit. The tan and grayish layers towards the top are the sands and gravels deposited by the glaciers over the last 10 to 50,000 years. And then right way at the bottom, you can see some red, hard rock. That's the iron formation, and what the reason why they dig these big holes is to extract that iron so we can make steel. And then right between those two layers, there's a thin band of grayish material. It's difficult to point out, but over on the left side of this picture. And that's the Cretaceous soil that we're looking for, that contains fossils from the time of the dinosaurs. We're going to talk a little bit about geologic time, and here's a very simplified picture. And this is what we talk about with strata. So each period of time in Earth's history has different layers of soil. The oldest ones are at the bottom, the newest ones are at the top. They all stack on top of each other. If you had one place in the world where every time period deposited some soil, you could find a column like this. Often in places like here on the Iron Range, we only have small slices. So here in Minnesota, we do have rocks from the Ordovician, Cambrian, and Devonian way at the bottom in the Paleozoic. And then we have some rocks, the ones that I study, in the Cretaceous, here in the middle in the Mesozoic. And then the sands and gravels on top are all from the Holocene, way at the top of the column there. So the soil that we study is called the Coleraine Formation, and it's named for the town of Coleraine, Minnesota, right here, because that's where the original type material is described from. The Coleraine Formation is pretty selective. It's really only found that we know of here in Minnesota. It represents an ancient river delta swamp system, and this would have been right on the edge of that interior seaway during the late Cretaceous. This is the only known location of this formation in the United States. There is a synonymous formation just north of us in Canada. And it's estimated that these soils are between 110 and 80 million years old. You'll see a diagram here of some examples of what a stratigraphic column would have looked like from here at Hill Annex. So this is part of the Mesabi Range geology. And you'll see here the one that's blown up, the Coleraine Formation. It's a Cretaceous. And this is a conglomerate, which means it's many different sizes of material all kind of lumped together. So think of a bottom of a river, or the edge of a lake, or the edge of the ocean, where you get rocks, you get sand, you get other things that all get piled together, and then they get solidified. So what did Minnesota look like at this time? 90 million years ago, during the time of the dinosaurs. This picture here shows you an artist's rendering of what we think it was. If you were standing and looking east towards Duluth, you would have looked upriver on a big river system coming down from the Giant's Ridge and the Arrowhead. It would have been flowing west into this Cretaceous seaway, flowing west towards the newly forming Rocky Mountains. Here's a map here that shows North America during the late Cretaceous. And you can see here the seaway that we talk about, the Western Interior Seaway, that bisects North America in two. So on the eastern half, Minnesota would have been part of Appalachia. It would have been right there near the end of Interior, marked with the star. This was about 90 million years ago, and this picture shows, hypothetically, the maximum transgression, or the farthest that the seaway would have flooded through the center of the country. Here's our artist rendering again. This time we've added a few animals that we know about, some of the evidence that we've been able to collect here to prove what sort of life was here on the Iron Range. Some of our previous research, one of our other inspirations for why we're doing this is this area is really vastly understudied, and the Coleraine Formation is not well known. And not a lot is known about the extent of all of the animal and plant life that would have lived here. So we do know about the Coleraine Formation and the fossils here going all the way back to the 1880s with Horace Winchell, Minnesota's first state geologist. He noted the existence of the Mesabi Iron Range, the iron deposits, and the fossils that were here. Then in the 1920s, Dr. Stauffer did some work up here, collected materials. In the 1940s, his student, Harlan Bergquist, published a journal review on a number of the mollusks, so snails, clams, oysters, ammonites. And those are the most described and detailed of the fossils that we know here. Then in the 1960s, Robert Sloan began to compile a lot of the previous research and form a compendium of all of Minnesota's fossil occurrences. And then Coban and Merriweather in the 1980s came back to compare a lot of Sloan's suppositions with other Cretaceous research and see how they matched up to the geologic timescale. We're going to talk a little bit about some of the finds that we've had here on the Iron Range. Here you can see a picture of a crocodile on the left. This is the Terminoneris. These specimens got up to 19 feet long. Along with that, we have a plesiosaur vertebrae. That's this specimen here, about just a little bigger than a baseball. Plesiosaur. The plesiosaur is the long neck aquatic reptile, so long neck flippers like the Loch Ness Monster. Some of our other finds here on the left, you'll see a teredo log. So this used to be a piece of driftwood or a former rotting log, and it gets infested with burrowing clams so that they burrow tunnels all the way through it. Their tunnels then fill in with sediment and preserve the log in this teredo form. Here on the right, you'll see a sample of some really exquisitely preserved fossil wood containing Pholis clams, another type of wood-burrowing clam. We also find examples of crustacean. Here's a piece of some crustacean exoskeleton, part of the external armor. There on the right are ammonites. We have a number of ammonite specimens, from ones that fit in the palm of your hand to ones that are almost 2 feet in diameter. You can see here, these are some pictures from our public fossil tours. This lady here a couple of years ago digging in the public fossil pile right here behind me actually turned up this ammonite. She managed to just uncover it, but could not extract it. So the slide in the middle there is me and my research partner, Doug Hanks, coming back a couple of weeks later to finish extracting it. You can see that we actually had to pedestal it out. It was about it would have fit nicely on a garbage can lid. That's about how big it is. During our first year, the specimen on the left, a possible turtle bone, was donated to the project and our research. On the right, this was a Ichthyodectes vertebrae. So Ichthyodectes is a big fossil fish, in the tarpon family. Here's an artist rendering of what the Ichthyodectes would have looked like. These fish would have gotten to about the size of a canoe, so 3 to 4 meters long, bigger than most fish that we have here in Minnesota now. And then lastly, 2 pictures here. The one on the left is a dromaeosaur claw, so this was found in 2015. And this turns out to be just the second dinosaur bone ever found in Minnesota, and the only one that is confirmed to have come specifically from a site. That hadrosaur vertebrae from Crow Wing County that we talked about, we're still trying to trace information about where exactly in Crow Wing County the person found it. And then the picture on the right here was a specimen found in 2017. This is very likely dinosaur bone number 3 for the state of Minnesota. And this is a reptile vertebrae. It's just a little bit bigger than a golf ball. And actually when we found it, it kind of looked like a golf ball with little bits of bone sticking out of each side. But you can see here in the picture all the multi-view positions after it has been cleaned and rendered. And we believe this is from an ornithischian type dinosaur. If you have questions for follow-up and would like to curious about something that we found or share or what we're working on, maybe catch up on some news that we found, things we found this year, feel free to email me, cretaceousmn@gmail.com. And maybe you want to consider a future fossil tour. Here's a picture of where we do most of our work right here in the Iron Range in Calumet, Minnesota at the Hill Annex Mine State Park. This is the public fossil pile, so if you come out in the summer on a Friday or Saturday and take a tour, this is the pile that you'll come to and will help you find your own 90 million year old fossil. Thanks for visiting today, and check us out on Facebook, Hill Annex Paleontology Project.